All right, good morning. How are we all doing? I hope we're doing well. I hope we're healthy. I hope that, the cabin fever isn't growing out of control, that we're still able to get out of the house in a healthy manner, social distancing, going on walks, doing something in the backyard, just getting that sunshine, yard work, maybe more yard work would be good. Just to get that sunshine, just to get that vitamin D. But yeah, it's like I said, it's definitely a trip of what's been going on with all this stuff. Interesting. So I don't know if there are people watching. So hopefully we get a few people watching. But let's start going over this stuff. We'll start with the 82-1. And with 82-1, very similar to another lesson already. It's just a repeat of the same lesson. Long story short, we got to be really good at being able to look at the substitution. And so we have x to the fourth minus 11x squared plus 24 equals 0. So we call this a quadratic type equation because if I substitute a value in, it looks like a quadratic equation. So in this instance, if I said u equals x squared, then this is going to become u squared minus 11u plus 24 equals 0. Well, now that's a quadratic equation, so you can solve it. This will factor into u minus 8 and u minus 3. So I get u equals 8 and u equals 3. Now I substitute back in. So I plug the x squared back in. Square root both sides. X equals plus or minus 2 root 2. And then x equals plus or minus root 3. And so that's going to be our answer. Now, what I'm going to do is I'm just going to kind of go over some of the substitutions for the other ones, but I'm just going to kind of dot it in terms of solving it because I'm assuming we already know how to solve a quadratic equation. That's basically what you're doing from there. So like number 3, x to the negative 2 minus x, or 6x to the negative 1 plus 9 equals 0. So this would be u equals x to the negative 1. So then this becomes u squared minus 6u plus 9 equals 0. That factors into x minus 3. U minus 3. So that means u equals 3 if you set it equal to 0 and solve. Now, doing that, substituting this back in, you're going to get x to the negative 1 equals 3, which is 1 over x equals 3. And so if you have 1 over x equals 3, now solving that, you're going to multiply both sides by x. So you get 1 equals 3x, and then divide both sides by 3. So you're going to get x equals 1/3. And that's going to be our answer. All right, this is just a typical parabola problem. Find the horizontal shift, vertical shift, all that different stuff. We went over that plenty of times. Just let me know in Discord if you guys have questions on that. For the finding the inverse, let's look at number 6. So you have x minus 2 over 2x minus 1. So switch the x and y, that's the first step. Now we want to solve for y, or get y by itself. So we have y in the denominator, so the first thing we want to do is get it out of the denominator, and we do that to both sides. Multiply. So you get x times 2y minus 1 equals, and then that's going to cancel out, so you get y minus 2. Distribute the x. So we have y's on both sides. So it looks like the terms for the y's are different. So we won't be able to just add them together. It's not like 2y and 3y. Combine them together and you get 5y. So instead of just being able to add them together, we have to group them together. So I still want all the y's on one side, and I'm going to bring everything else to the other side. So you're going to get 2xy minus y equals x minus 2. Right here, there's a y in common, so you can factor out that y. I just want to make sure I add that. Plus x. Plus x. There's a y in common, so I factored out the y. Good. And so now I can divide by this. And so I get y equals x minus 2 over 2x minus 1. And it's the inverse to itself. For number 7, it says x squared minus 10x, where x is greater than or equal to 5. This right here is just a domain restriction, and it's there. So if we were to look at the intercepts here, you're going to get at 0 and at, I'll say that each of these is 2. So 2, 4, 6, 8, 10. So that means that 5 is somewhere in the middle. Now, I don't know where it is exactly among the y, but that's basically, if this is where the y value of that vertex is, that's essentially like a sketch of the quadratic. What it's saying here with this x is greater than or equal to 5 is you're chopping this part off. And the reason why they're doing that, they're basically restricting the domain so that when you do the inverse of it, it's also a function. So you just have to be aware that when you switch the x and y and you get y by itself and you solve for it on this, so you're going to get x equals y squared minus 10y. And so now we need to solve for y. It looks like we're probably going to have to complete the square. So b over 2 squared, that's plus 25. So we're going to add 25 to both sides. So I'm going to get x plus 25 equals, now this factors. So we're going to get y minus 5 squared. Now I can square root both sides. So I'm going to get the square root of x plus 25, plus or minus. And you're going to see this here in a second. So we get plus or minus, and then we're going to get y minus 5, and so I'm going to add 5. So you're going to get plus or minus x plus 25 plus 5 equals y. Now, here's the thing. Technically, on our parabola, when I'm going to just draw it in red, even though there's that domain restriction. the idea here is that this one represents the plus, this one represents the minus. Because when it gets flipped, and let's look at, I'm going to show it on Desmos, I think it might be easier. So if I had x squared minus 10x. Now, let's look at our our inverse. So we had, I wonder if we can do plus or minus on this. I don't think so. Yeah. Okay, so we have to do both. So we have x plus 25 plus 5, and then negative square root of x plus 25 plus 5. Okay, so just looking at this image, we can tell that these are inverses. They reflect over the line y equals x, so these are inverses of each other. Now, the issue is the fact that if we look at this one right here, this plus or minus square root of x plus 25 plus 5, those values are not, or this graph is not a function. So what the problem did is they said, okay, let's restrict the domain here, and let's only reflect this. This is the only piece that we have on our graph. So that means this piece is no longer there. So it's only this one that's getting reflected, which happens to be this blue one. Now, algebraically speaking, when we solved for it, we had that plus or minus. Well, because of that domain restriction, we have to get rid of that plus or minus. It's only the plus. So your answer is that, without that minus. And it sucks, only in the sense that it was like, it's one of those things that it's like, it's really fun to go over in class, and we get in Desmos, and we look at things, and we do certain things with it. But we can't do that. But anyways, that's kind of like the premise of that problem. You restrict the domain here, so now that when you do the inverse, it's now a function. Any comments or questions on that? I know I have one viewer. Okay. All right. So let's talk about these composition of functions. So like on number 9, let's look at f of g of -1. So I'm plugging -1 into g, and then I'm plugging all that into f. So if I plug -1 into g, remember we have to think of this as f of g of -1. So I'm plugging -1 into g. What is that going to equal? Oh no, I'm going to have an imaginary value. So that's going to give me square root of -3, which is root 3i. So the root 3i is getting plugged into my f. So if I plug that in, so that's f of root 3i, that's going to give me 2 times root 3i over 5 minus root 3i squared. And so that's going to be 2 root 3i on top. On the bottom, root 3 squared is 3. I squared is -1. So negative and a negative is a positive. So I'm going to get 2 root 3I over, well, this is going to be 5 plus 3. So that's going to give me 8. The 8 and the 2 reduce. So you get root 3I over 4. Okay. We've seen a lot of the lines. Find the line parallel, find the line perpendicular. So we've seen a lot of that. If you have any questions on it, just let me know. Maybe we can move on to the average rate of change. So to remember the formula, the average rate of change is f of b minus f of a all over b minus a. So it's going to be, so number 12, that'll be f of 16 minus f of 0 all over 16 minus 0. So f of 16 is going to give me square root of 16 minus the square root of 0 all over 16. Square root of 16 is 4. Square root of 0 is 0. So you get 4 over 16, which is 1/4. Okay, so that's 82-1. Whoops. That was weird. Everything just went down. There we go. All right, so that was 82-1. Let's go ahead and move on. Now we're on 83-1. And 83-1, we're taking a look at how do we simplify complicated or more complicated exponential expressions. The weird thing about this entire thing is it's not as visual in our brain. So it's one of those types of things where as long as we stick to the rules, as we stick to the definitions, it starts working itself out, and we just have to try stuff. So it's almost similar to the identities, where it was like, I don't know where this is going, and so because I don't know where this is going, this is kind of weird. It's kind of similar to that. So on number 1, this is the power rule. And the power rule just says if you take in an exponent to the exponent, you multiply them, the exponents together. So this 5 to the first, so it's 1 times 4/7. So you're going to get 5 to the 4/7. Then 3 times 4/7, so that's going to be x to the 12 over 7. And then 5 times 4 over 7, so you're going to get z to the 20 over 7. And then it's a squared, so the 2, so we're going to get a to the 8 over 7. And so then these values are, the condition is only positive exponents, and so it is only positive exponents. It's okay that it's a fractional exponent. It's okay that the number, the value on top is greater than the bottom when it comes to the exponent. You're going to find that when you get into calculus, you're going to do a lot of converting a square root into exponents, and it's much easier just to leave it as an exponent. So you're not required to put it back in a square root form. So let's look at number 2. So I have the square root of 9x minus 81 over the fifth root of x minus 9 to the fourth. So a few things here. First, can I simplify my square root at all? If there's ways for us to simplify the square root, we need to simplify it. And then we should convert, to see if things will cancel out, we should convert our roots into exponents. So on top here, there's a 9 in common. So I can actually factor out that 9. And I get x minus the square root of 9 times x minus 9. Well, the square root of 9 is 3. I haven't even touched the bottom. So that's 3. And then the square root of x minus 9. On the bottom, I don't want this written as a root, so I can write that as x minus 9 to the 4/5. And I'm going to rewrite this one here. So I'm going to get 3 x minus 9. It's a square root, so that's going to be 1/2 over x minus 9 to the 4/5. So now, one of the rules is that when you're dividing exponents and the bases are the same, so these are both x minus 9s and x minus 9s, you can subtract these. So I'm going to do that math off to the side. 1/2 minus 4/5. I have to find the common denominator. So I'm going to get 5 minus 8 over 10, which is negative 3 over 10. So this is going to give me 3 and then x minus 9 to the negative 3/10. Now, one of the conditions says only positive exponents. So because it's only positive exponents, this is going to get moved to the bottom. So this is going to become 3 over x minus 9 to the 3/10. So go ahead and give it like an attempt on number 3 and 4. And then if you have a question on it, just let me know. But as a hint, because these are pluses, this 2/3 thing does not distribute. You do not distribute that. Don't do it. You can only, the only time distributing happens is if it's multiplication. So the reason why that this 4/7 was able to go to every exponent was because they're all being multiplied. But here, because of that plus, you cannot distribute that 2/3. The other piece to this is that we have negative exponents here. You're going to want to move those to the top. So like those are just a few hints to that. Let's look at number 5. So for these, I want to convert them all into exponents. It even says write as an exponent and simplify. It'll just make everything easier. So let's do number 5. So this will become x to the 7/4 times, and then the next one is x to the 4/3. Now, because we're multiplying, you add these together, so I'll do that off to the side. Find the common denominator. This needs a 4/4. This needs a 3/3. So you're going to get 21/12 plus 16/12. So that's 37/12. So this is going to equal x to the 37 over 12. And we can leave it as an exponent. Let's look at number 7. So we're going to have x minus 3 to the 1/3 times, now converting that second piece into an exponent, that is also going to be x minus 3 to the 1/3, and it's over, converting that into an exponent, x minus 3 to the 1/7. The root always goes in the denominator, the exponent goes on top. So combining the top together, we're just going to add these. So you're going to get x minus 3 to the 2/3 over, and then you have x minus 3 to the 1/7. So now, when it's on top and bottom, you have to subtract. So you're going to get 2/3 minus 1/7, common denominator. So you're going to get 14 minus 3 over 21. So that's going to give me x minus 3 to the 11 over 21. I know, it's weird numbers, weird fractions. It's kind of like you've seen this before, but you haven't. It's put in like a weird way. That's this type of algebra. We're in that weird realm right now. All right, solving inequalities. We've looked at that a lot. If you have questions, any questions on that? It's where you find the values, you put it on the number line, you test true or false, and then you shade wherever it's true, and that's your answer. And then questions on the difference quotient. Remember, the goal is to cancel out the h. Here, I'll set up the difference quotient, because I'm pretty sure a lot of us know it. It's just setting it up. So the f of x plus h minus f of x over h. So that means plug in x plus h. Minus my f of x. That's all over h. And so multiply this out, distribute, right? That negative distributes. And then all the values that have x's are going to cancel out. And then eventually you're going to have only terms with h. Factor out the h. And you're going to see how it's going to cancel out with this value here. But yeah, so go ahead and take a look at that and let me know if you have any questions, even on the next time we meet. And then same thing with 8, 9, and 10. If you have any questions on that, let me know. Before we wrap it up, are there any issues, any concerns? Okay, cool. Well, for those who joined, thank you very much for joining. I hope you have a great day. I hope your weekend is also just as splendid. Our pacing going through this is we're going through it pretty well. So we should be getting done with this a little bit early, and then we'll have a calculus review thingy. That'll be good as we head into calculus. Other than that, appreciate you guys. Thank you for being here, and have a great day.